My student, hello, good morning. Today's the being of the electricity resistance. I have taught you the combination of resistors in two ways. One is series and one is parallel. And what are the benefits of the combination of series and parallel? I have described. Yes, now a question comes in mind that why the household wiring is done in parallel. What are the benefits of the wiring done in parallel? Why not done in series? Though your household wiring is in parallel combination, every electrical equipments are connected with each other from the source of energy in parallel. Why? And why? What are the benefits of the parallel combination? The first benefit of the parallel combination of the electrical components are if one component is failed. Suppose so many things are connected in your houses, fan, a number of fans, tube lights, bulb, electric heater, AC, cooler, fridges, and so many other electrical appliances. All are connected in parallel, and if one component fails, then the other component is not affected. Means if one is breakdown, then other continue to work in parallel combination. This is the benefit of the parallel. See here, if the components are connected in series. For instance, I am showing the resistance only. And anyhow, the middle resistor is broken. Then what happens? The electric current is coming by the source. Here I, it passes through this device. I comes out. Here the I enters, but it does not come out here because the path is broken. Therefore, the circuit is not complete. The circuit is not completed and the whole system breaks down. And if these three components are connected in parallel, see, the three resistors are connected in parallel. They are three bulbs, suppose, and they are connected in parallel. And here, from source of energy, I current is supplied. Then the currents are distributed according to the requirement of the electrical components. If resistance R1 required I1 current, then it takes I1 current from the source. If R2 required a I2 current, then a I2 current is going through this. And if the R3 component required I3 current, then from the source I3 current is available. And if the circuit is broken here, suppose here the circuit is broken, then only R1 stop to work, but R2 and R3 electrical component is continuing. They are doing their own work. Only R1 is stopped. This is the one benefit, first benefit of the parallel combination in household wiring. And the second, each component gets the required current and current divided appropriately in parallel combination. Here I have told the second point also. R1 how much current required, it is distributed. According, we know that R is equal to B by I. According to R, the current comes. So, the requirement of the every electrical component is fulfilled in parallel combination. And the third, in series combination, if you put on a T here, suppose, because everything is in series, you have put on a switch here and you want to stop this third device R3. Then to stop that, if you switch off here, then what happens? The total system stops. The working of the total household equipment is stopped if the connection is in series. और घर की वायरिंग सीरीज में है तो स्विच ऑफ करते सारे इलेक्ट्रिकल कंपोनेंट बंद हो जाएंगे क्योंकि करंट का फ्लो सर्किट में ब्रेक कर जाएगा लेकिन इन पैरेलल कॉम्बिनेशन we are able to put separate switch for every electrical component. We have chance to put separate key for every electrical component, and if we want to stop 1, 2, or 3, or only we want to on one component, then the other 2 or 3 or 4 feet are out. अगर हमें फ्रिज चलाना है तो सिर्फ हम फ्रिज के स्विच को ऑन कर दिए बाकी स्विच ऑफ है इस तरह पैरेलल कॉम्बिनेशन में हम ईच एंड एवरी कंपोनेंट के लिए एक सेपरेट स्विच रख सकते हैं ड्यू टू दिस फर्स्ट बेनिफिट इज इलेक्ट्रिकल एनर्जी इज सेव्ड द डिवाइसेस आर आल्सो सेफ and as per requirement, we use our electrical equipments. These are the benefits of the parallel combination household wiring. Now, come back. In the previous class, we have learned the combination of resistors, and then we find the equivalent resistance of the parallel combination and series combination. For parallel, we have got the equation 1 by R equivalent is equal to 1 by R1 plus 1 by R2 if resistors are 2. And in series combination, R equivalent we have found R1 plus R2. And what are the special benefits of these combinations you have learned very well. Here we are going to solve a combination in which parallel and series combination, both combination is present. Then how we will find the equivalent resistance of that circuit, of that combination. At first, we solve simple problems related to the equivalent resistance, which are connected in parallel and series, and then we solve combination of the resistors, in which the resistors are connected in series and parallel both. For example, I am showing an example in which the resistors are connected in series. Take one resistor R1 . R2, R3, and it is R4. Then we have to find, and the value of the R1, R2 are 3 ohms, 4 ohms, 5 ohms, and 6 ohms. Then we have to find the equivalent resistance at A and B. See this diagram, my children. What do you think? In which way they are connected? I think that you are showing which type of combination is it. You are confusing, but I am going to clear you that what type of combination it is. In engineering or in higher classes, the teachers, the professor taught that they split the diagram in simplest form. I try my best to split this diagram in simplest form. Each and every diagram is split by me in simplest form, and then you are able to understand that the combination is in series or parallel. Say the A terminal current is coming here, I. Suppose the A is here, this is A, and the resistor R1 is this. The A is a spare, and the second in is connected with the R2. Connect. The second in is connected with R2. This is R2. This in is connected with R1. See it? The R1's one in is connected with R2. And then second in of R2 is connected with R3. Here, R3. And R3 is again connected here with R2. And the second in of R3 is connected with R4 here. And the last in is here B. This in is A and this in is B. It means this type of diagram shows the series combination of the resistors. And the magnitude of the resistors are 3 ohms, 4 ohms, 5 ohms, and 6 ohms. And therefore the R equivalent is equal to R1 plus R2 plus R3 plus R4. And the magnitude are 3 ohms, 4 ohms, 5 ohms, and 6 ohms. The result is 6, 5, 11, 4, 15, 3, 18 ohms. The equivalent resistance of this series combination is 18 ohms. My children, this is a series combination. Now I am giving you an example of parallel combination and its equivalent resistance. See, a parallel combination. In parallel combination, one end of every resistor is connected at one place and another end is connected at one place. And only 2 ends are available to connect with source of energy. The blackboard, whiteboard is not supporting me. Please wait for a moment. Here is a diagram or what nonsense. This is R1 resistor. The second is R2 here, and third is R3 here. The one in of each and every resistor is connected at a point A, and the another is connected at point B. And you have to find the equivalent resistance at end A and B. You have to calculate the equivalent resistance at point in A and B. The value magnitude of the resistance are 3 ohms, 3 ohms, and 3 ohms. Therefore, R equivalent we have learned in previous class, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Putting the value of R1 by 1 by 3 ohms plus 1 by 3 ohms plus 1 by 3 ohms is equal to 3 by 3 ohms, 3 by 3 ohms, and this is equal to 1 ohm. R equivalent is equal to 1 ohm. I have taught you in the previous class that the equivalent resistance is less than each and every single resistor present in the circuit. Here, R1, the magnitude of R1 is 3 ohms and the equivalent resistance is 1 ohm. The magnitude of R2 is 3 ohms, the magnitude of R3 is 3 ohms, but the equivalent resistance is 1 ohm. It means if you want a less resistance from the heavy resistors having heavy magnitude, then you will combine them in parallel combination. This is a second example for parallel combination. And now I am giving you a diagram in which parallel and series, both combinations are present. See, my children, these diagrams are very vital for your board examination. Please be careful. You have to learn for your board examination, not for a school examination. So be careful. On the classes, these video classes are so helpful for you. Don't careless because when the school are open, this chapter is not taught in the classroom. But the problem comes in this teacher mood. Let's be careful. Speech. Yeah. One diagram is like this. In this diagram, five resistors are in C, and they are connected with each other. What type of combination is it? You see. The end is heavy. You have to find the equivalent resistance at the end heavy, and the resistors are R1 magnitude 5 ohms, R2 magnitude 3 ohms, R3 magnitude of the 2 ohms, and R4 magnitude 5 ohms, and R5 magnitude 5 ohms. You have to find the equivalent resistance at the end AB of this combination. Now, the first problem is that this combination is of what type? It is parallel or in series or in both. The diagram shows that the series combination and parallel both are present in this diagram. Then how you are able to solve this problem? As per my meaning, I am going to show you how you can split this diagram easily. You start from A, the current enters from A, okay? And it passes from R1, reaches to this point. I current reaches here. And this point is B. At first draw this diagram. Here, point is A and the resistance here is R1. And the magnitude of the R1 is 5 ohms. Right? Now here is point B. And here it is a junction where the current is split into two loops. See, I am also going to split here the like this. The current in this I current is coming, then by this route I1 is passing, and from this I2 current is passing. From in this path, 5 ohm is connected, and the resistance name is R4, and magnitude is 5 ohm. In this path, R2 is connected. Correct? R2. What is the magnitude? 3 ohms. And the second end of this R2 is connected with the one end of the R3. Correct? R3 here. R3. The magnitude of R3 is 2 ohms. And the second end of R3 is connected with R4. Correct? This is R4 second end. Here, both are connected. This junction point. And from here, the one end of R5 is connected. Connect R5. R5. And the potential is 5 ohms. And this end is B. This end is B. The split diagram. Now see the split diagram. These two resistors are connected in series. R2 and R3 are in series. And then the equivalent resistance of these two resistors are connected with R4 in parallel. Because equivalent resistance of this resistor is converted into a single resistance R. Yes, and the result is 5 ohms. 3 plus 2, 5. And then one end of this is connected here at in this point, and the R pole is here. The magnitude is 5 ohms. And the second end is connected here. And after this, the R1 resistor is connected here. Magnitude is 5 ohms. And R4 resistor is connected here. Magnitude is 5 ohms. Now, this R and R4 are connected in parallel because one end of R and one end of R4 is connected here at a single point, and the other end of R and R4 is connected here on this point. It means the current is split in this path, but the potential, if you measure here, it is same for R and R4. So this combination is in parallel. So here, after this step, you have to find the equivalent resistance in parallel of R and R4, 1 by R equivalent. ये कैमरे में नहीं आ रहा, देखिए बीपी सब आ रहा 1 by R equivalent is equal to 1 by R plus 1 by R4. Write the magnitude. 1 by R is equal to 5 ohms plus R4 is also 5 ohms. The result is 2 by 5, and therefore R equivalent, if you want so it's parallel, it is 5 by 2. The result is 5 by 2 of these three resistors combination. Now they mix together and form one resistance. And then the third diagram I am going to draw for this. See here. After this, the diagram becomes like this. This is R1, and the combination of these are equivalent. Here, are equivalent, which is in parallel. Here, value of this parallel combination 5 by 2, yani 2.5 ohms, and it is 5 ohms. And at the end of this combination, R4 is connected. Here, the R4 and the magnitude of R4 is also 5 ohms, and the last thing is just B. It is now this combination is series, and the result are equivalent is equal to 5 ohms plus 2.5 ohms plus 5 ohms, that is 12.5 ohms. This is the result of this question. This is called a splitting of the diagram. Step by step you have to split. For your understanding, I have drawn this diagram in this way. Again, I am going to tell you a proper way to solve this numerical. What is the way to write in the examination, board examination, to solve this problem? I am going to describe you on your board. Please be careful. In examination, it may be possible that the name of the resistors are not given. One, R1, R1. The name of resistors are not given. It may be possible. Then you have to write the name of the resistor systematically and the magnitude of the resistor in the diagram at first. Then you will start write the combinations of the resistors and their equivalent resistance. At first, you are going to find the equivalent resistance of R2 and R3, which is connected in series. Then name it RS, series. To solve the series, you will write RS. If RS1, you can maybe write RS1, and that is R2 plus R3. And then write the magnitude 3 ohms plus 2 ohms, and the result is 5 ohms. Now, this is combined together and one resistance is called 5 ohms, and thereafter this equivalent resistance is connected with R4 in parallel. So you will write 1 by Rp is equal to 1 by Rs1. This is equivalent resistance 5 ohm. This combination, and 1 by R4. You have to write. And then write the magnitude 1 by 5 ohms plus 1 by 5 ohms. And the result is 2 by 5. Therefore, Rp equivalent is equal to 5 by 2. Means 2.5 ohms. Of the third stage, the R1 and the value of this combination are equivalent, and this Rp, R5 is connected in series. Then you have to write R equivalent series, that is R1 plus this Rp equivalent plus this R5, and the magnitude of this resistance are 5 ohms, 2.5 ohms plus 5 ohms, and the result is 12.5 ohms. And some children also draw the diagram of this splitting, which I have drawn before. So this is the example in which the resistors are connected in series and parallel. I have shown you. Now, so many questions comes in front of you which you have to solve. Some other numericals related to this chapter I am going to describe you, explain you, solve you, and then I will give you home assignment. And the home assignment is from your NCERT book. The numericals are given to you related to this equivalent resistance. You have to solve that numericals in your fair notebook. Some other numericals related to this wing of the electricity related to the resistance are as follow. The question is, one question I am going to solve here. Very simple, but very necessary for you. The question is, a diagram is given here. Why? A diagram is here. So, yes, a diagram is given here. One resistance here, it is R1, and the magnitude is 5 ohms, and the second resistor is here, is 5 ohms, R2, and a ammeter is connected here, and also here is a seal is connected. This is the diagram for you. And the question is, what is the reading in ammeter in the given figure? What is the reading of ammeter? What is the reading of A in given in figure? It means you have to calculate the current passing through this circuit. Then according to Ohm's law, you know B is equal to I into R. Therefore, I is equal to B by R. Here are two resistors. You are saying they are in series combination. Therefore, Rs is equal to what? 5 ohms plus 5 ohms. That is 10 ohms. You learn that in series combination, the magnitude of current is same for each and every electrical component or resistance. Current is same, but potential is different. And for the R1 and R2 are connected in series, so the equivalent resistance is 5 ohms. Therefore, I is equal to what? I is equal to R to get 10 ohms. But what is potential? Here is a diagram. Two parallel lines are present here. What does you mean from these lines? The parallel lines, one big and one small, so they say one cell, and the potential is 1.5 volts. It indicates that here the potential is 3 volt. The diagram shows 3 volt because two parallel lines are present here. So you have to write the volt 3 volt, and the result is 0.3 ampere. The current is flowing in the circuit is 0.3 ampere. These type of numericals are asked in your examination, and you have to solve the problems. A next question for you of different type. See, another diagram of different types, and the combination in this diagram is in parallel. The resistance are connected in parallel. The two resistance are connected in parallel. This I current is coming from the source. A resistance R1 is connected, R1, and the next resistor R2 is connected in circuit, and now the second end of the circuit. This is B, and this end is A. The resistance of these two resistors are 2 ohms, and its also magnitude is 2 ohms. Then the question is how much current is passing through this R1 resistors and how much current is passing through this I2. If I change the magnitude of this resistor, it becomes 3 ohms. Then how much current is passing through the R1 and how much current is passing through the R2? The question is given like this. Find I1, I2, and I in the given diagram. Find I1, I2, and also I. Find I1, I2, and I in the given diagram. Yes, you have to find I in the given diagram. Then the problem is what is the potential difference at the end of the circuit? That is here 5 volt. 5 volt. It is connected with the source of energy. The potential difference of that source of energy or same is 5 volt. Okay, then you know that this is in parallel combination. The one end of R1 and R2 resistance is connected at this A point, and the another end of these two resistors are connected at the point B. So it is a parallel combination. To find the I, you have at first find the value of this equivalent resistance of this parallel combination. If you find the value of the equivalent resistance of this parallel combination, then the total current is fine. And then you are able to split the current into I1 and I2 according to the resistance. The R equivalent, 1 by R equivalent is how much? 1 by 2 ohms plus 1 by 3 ohms. LCM 6 ohm, 3 ohms plus 2 ohms. The result is 5 ohms by 6 ohm, and R equivalent is equal to 6 by 5, that is 1.2 ohms. The equivalent resistance is 1.2 ohms. Then I is how much? I is equal to what? According to Ohm's law, V is equal to I into R. Therefore, I is equal to V by R. The potential difference is how much? 5 volt, and the resistance is 1.2. And the result is how much? 50 by 12. 25 is 6, 4.16 ampere. Near approximate, not correct. This is the current passing through this circuit. And therefore the question arises that how can we reach the current I1 and I2? I1 is how much? According to the resistance current flow. So you know the resistance of R1 is 2 ohms and the resistance of R2 magnitude is 3 ohms. Then you have to put the value of R 2 ohms for I1 and 3 ohms for I2. Some questions you have to solve from the NCERT book, which are given in your book. Solve the problems. If you are getting any trouble to calculate the equivalent resistance, then you will ask the question via admin, sir. You ask with WhatsApp, and then I will solve the problem by talking by voice or by on paper. So please, I request you that do labor hard, at least take class, study 12 hours per day. It is necessary for you because you are a board examining, you are not a school examining. And the time is passing. Your school may be open on 15 minutes.